In this video, we are going to be looking at scientific notation. So we are going to get some very big or very small numbers, and we're going to write it in scientific notation. And then we're also going to do a couple of examples where it is given to us in scientific notation, and we are going to write that in standard form. All right, so let's jump in. What is scientific notation? Well, it's exactly what it says. It is a notation. It is a way of writing either a very big number or a very small number, just in a specific notation that, let's say, it is just easier to kind of read or to digest and see how big or how small it really is. So let's just get some sort of a definition of the kind of format the notation takes on. So let's say, for example, it's when you've got a number, a, and then we write it as something with a base of 10 and an exponent. Let's make the exponent p. It takes on this form. It's always a base of 10. Why? Because while it's very easy to multiply or to divide with a base of 10, because we're basically just moving our comma. That you know from primary school already. Then your base of a over here represents a number. It represents a number that is between 10 and 1, and it can also be equal to 1. So what would be an example of a number? What am I talking about over there? So it can be 1,578, because that is between 10 and 1. It can be 3,712. It can be 4. It can be 9.5. But it can't be 10. We're not including 10. So it's basically a number where we've got a 1 digit in front of the comma, if I can put it like that. All right. And then let's look at our p, our exponent. What can our exponent be? Well, our exponent must be an integer. An integer. So what does that mean? A positive or a negative number? That can mean that it can be a negative 2, it can be a negative 10, it could be a positive 8, it could be a positive 3. Note there, they are integers, so we're not looking at the decimals. It can't be like a 1,5 or whatever. However, the one exception is just that our p can't be 0, because then the notation would fall flat. Okay, so now with this format in mind, let's go ahead and do some examples. So for the first one of you, I actually want to make sure that we can just see that. So let's look at writing this number in scientific notation. All right. What we want to do so that it kind of fulfills that condition for A is we want the decimal grade 9s to be there after the 6,72 blah, blah, blah. Right? Because our A must be between 1 and 10. So we want 1 digit before the comma. So when we do that, currently the comma is there. Let me just do that in a different color. We want the comma to be there. So basically we are moving it 1, 2 spaces. So we are basically dividing by 100, right? We are basically dividing by 100. Our comma is moving 2 places to the left. We are making this number that they gave us, we are making it smaller. All right. So we know that so far it would be 6,7212. That sorts out our A value. All right, but we can't just change to a sum. We are just writing this in a different notation. So our notation must now make sure that we don't change to the value of 672,12. It just looks different. So if we multiply this with 10 to the power of, how many zeros did we have there? 2. To the power of 2. We didn't change to the sum. We're just rewriting it in a different way. This over here still has the same value as that. It's still 672,12. It just looks different. Because if we were to multiply this out, if we times by 10 squared, it's just 100. It means that we're taking 6,7212 and we are multiplying that by 100. And if we multiply that by 100, we still get the same answer than we had in the beginning. You can check that on your calculator. All right, let's look at the next one. Note that our exponent with the first one was positive. Now let's look at the next one. So over here, to get it into that form where our A value must have one digit in front of the comma, I'm going to move this one up. I want my comma to be there, right? Let's see how many positions I think that's the right word, did we move it? 1, 2, 3, 4, 5, 6, 7. So in order to get it there, the comma there, we are multiplying it with the 7 places, so that would be 10 to the power of 7, or 1, 2, 3, 4, 5, 6, 7. That's how many times we moved it, right? Okay, now our A is sorted. We've got 2, comma, 3, 5. Now the comma is where we want it. But remember, we are not changing to that very small number over there. That might be like the diameter of an atom or something. I don't know if that's realistic, but that's obviously a very small number that we are just writing in a different scientific notation. Then we have to times this with the base of 10, always a base of 10. And now we just need to talk about what our exponent is going to be. Because remember, when we multiply this out, we want to get back there. So we want to make this number of 2,35 a lot smaller. So that means that our exponent in this case is going to be 7, yes, but a negative 7, meaning that our comma would then move in that direction. So when we've got 2,35 and we want to get back to the original value, then it means we're going to move it back 1, 2, 3, 4, 5, 6, 7, comma. Let's fill those with zeros. 1, 2, 3, 4, 5, 6 zeros. So over there, I'm just going to count that again with you. There is our original that they gave us, right? There's the original. And then 1, 2, 3, 4, 5, 6, 7 place we move it. That's where we put our comma. So we didn't change to the value of the sum. We are just rewriting it in a different way. So let's just quickly summarize it. When will the exponent, let me highlight it, when will the exponent be positive? And when will the exponent be negative? Well, the exponent will be a positive when we are making a big number smaller when we write it in scientific notation. See, we started with a big number, 672,12, and we made that a smaller number, 6,7212, and then we just times it by something that we don't change to its value. When will the exponent be a negative? The exponent will be negative when we're taking a very small number, like we had there in the beginning, right? That very small number of 0, so many zeros. And we are making it, or we are writing it as a bigger number in order to write it as scientific notation. That might be a nice way of remembering it. Try some of these on your own and see how it goes. Watch it again if you must. It's a new idea, or if it is a new idea to you, then it takes a little bit of time to get used to. Now for this part, do you notice or do you recognize this as our scientific notation? There's our A value, and there is our base, and there is our P value. So there is our A value that is in fact between 1 and 10, yes. And then our base is always 10, and then our exponent, our P, is an integer, a positive or a negative number, and it's not equal to 0. So it's definitely scientific notation. Now we have to write it in standard form. So we're basically just going to work that out. Let's do that. Well, if we're timesing it by 10 to the power of 3, it just means that we are timesing it by 1,000. It also means that we are moving the comma 3 places to the right in order to make it bigger. So you can either put it in on your calculator just like that, or without your calculator. What I'm going to do is I'm going to just write it over quickly. Times 10 to the power of 3, which is just 1,000. And what I can do is I can literally just take that comma and move it 3 to the right. Times it by 10, 100, 1,000. The comma would now be there. So if we just add those zeros, so there would be a 0 there, and I mean just 0 there. So it will be 230 5. No, there's an extra 0 there. So 2,350. It's this one over here, hey, because the new comma is now there. And that should be our answer. Put it in on your calculator and make sure that you agree. For the next one, we've got 1,23. That's our A value. There is our base of 10, and there is our p-value, which is an integer, so all looks good. That is in perfect scientific notation, and now we're just going to write it in standard notation to see what that looks like, written as a normal number. So we've got a negative exponent of 6. So what does that mean? Does it mean we're going to move the comma to the right, grade 9s, like in this direction, or are we going to move the comma to the left? I hope that you're saying to the left, because we are making that number of 1,23 a lot smaller. How many places are we going to move that comma? We're going to have to move it 6, because that 10 to the power of negative 6 gives us 6 zeros. So let me just write this over. So I've got my 1. Let me just create a bit of space there. Actually, I've got my 1, 2, 3. Currently, the comma is there. Now I'm going to move it with 6 places. 1, 2, 3, 4, 5, 6. The comma will now, my new comma, will now be there. And now I'm just going to go add my zeros. So when we write this, it would be 0, comma, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then 1, 2, 3. So there is my standard notation, my normal number. That's a very small number. And in scientific notation, it looks like that. So we took the scientific and write it as a normal number. All right, try some of these on your own and see how they go.